we're going to do one more problem on ellipses. We've got to find the center, foci, and major and minor axes of this ellipse. 4x squared plus y squared minus 6y plus 5 equals 0. Again, we use the same techniques we always have. We write down the standard equation, x squared over a squared plus y squared over b squared is equal to 1. And we try and rearrange this equation to resemble the standard as much as possible. Like I've mentioned previously, I normally divide through by the lowest common multiple of the factor multiplying the x squared and y squared terms. In this case, 4 multiplies x squared and 1 multiplies y squared. So I divide through by 4, which is the lowest common multiple of those two numbers. I end up with this. And by completing the square here, which we almost always do in conic problems, we always complete the square. And a little more algebraic manipulation, I end up with this final form here, which resembles the standard form, as you can clearly see. What now can be gained from this new rearranged form of the equation? We can immediately tell the center is 0, 3. So that's our center, 0, 3. Now, our next question. Which axis is the major axis? Which axis is the minor axis? Look here. The y denominator is greater than the x denominator. Hence, in this case, the vertical axis is going to be the major axis, and the minor axis is going to be the horizontal axis. Alright? So in this case, we're not dealing with the same major axes and minor axes as we have previously. So now we know which axis is which. How do we now find their lengths? Well, if a, as we do in the standard equation, if a refers to half the length of the horizontal axis and a squared is 1, then a must be 1, and hence the minor axis, in this case the horizontal axis, is going to measure 2 times 1, which is 2 units. Likewise, to find the major axis, if b squared is 4, where b refers to half the length of the vertical axis, then b is going to be equal to 2, and the major axis length is 2 times 2, which is 4. Now at this point, it might be a good idea to think, what does the ellipse look like? I've drawn a rough diagram over here. It's an ellipse that's sort of standing up with center at 0, 3. It's got a major axis here that's vertical, and you will have 2 foci, which are a times e units away from the center on either side. Now this is where we have to pay extremely close attention to some of the references that we're making. When we talk about axis lengths, like here, when we talk about this equation, a refers to half the length of the horizontal axis, and b refers to half the length of the vertical axis. However, we covered in the second video of ellipses, where we talked about the mathematical relations, that a and b don't necessarily refer to horizontal and major in mathematical relations. They refer to the major and minor axes. And so, when we say that there is a focus AE units on either side of the center, we don't mean A in the sense of being half the length of the horizontal axis. We mean A to mean half the length of the major axis. That's extremely important. In this reference, when we talk about AE units away from the center line, there are foci on either side, we mean A as being half the length of the major axis. Alright? And obviously E is eccentricity. We're now going to revisit what we used in the previous 2 videos, the mathematical relation b squared equals a squared times 1 minus e squared, horizontal axis. So 1 is equal to 4 times 1 minus e squared. If we substitute, we find e to be square root 3 over 2. And when we find AE, taking into account that a is half the length of the major axis, we find AE to be square root 3. So we know that this distance here, AE, is always going to be square root 3 for this ellipse. If we know the center is 0, 3, and we know the distance on either side is going to be root 3, we know that the foci are going to be 0, 3, plus root 3, and 3 minus root 3. Alright? This is a very good problem to illustrate what I was trying to stress in the first few videos of ellipses. In this equation, I'm going to repeat this, A refers to half the length of the horizontal, B refers to half the length of the vertical. However, when we talk about mathematical relationships, when we talk about the distances between the center and the foci, when we say b squared equals a squared times 1 minus e squared, b refers to half the length of the minor axis and a refers to half the length of the major axis. So you have to bear those differences in reference in mind when solving these equations. Alright? I think that takes care of this problem. Thanks very much for listening.